Hello, I'm Marcus Walker. I'm here at San Bernardino Valley College. I'm an AA transfer student working on my mathematics to transfer into mechanical engineering at a university. I'm working on the CaSGC program for NASA. We are a STEM project. We've been working all summer long. We've been trying to get this done. We have 4 roles. I am communication. Then we have our design, which is Adrian. Then we have our hardware and our software, which is Luis. And then we have our physicist, which is Joseph. Some of the challenges I faced as a communications of this project were forms of communication that make sure we can all get in touch with each other in everybody's daily lives and schedules, cooperating together to make sure we're all on time and have all our ideas come across as fluently as possible to each other.
Hi, my name is Adrian Estrada. I'm here at San Bernardino Valley College, and I am part of the design team here. Basically, what I've constructed is a satellite, and I was able to do this using the software Tinkercad. I just grabbed other objects and I played with them around, and other people's designs and looked for inspiration. But as for a challenge, I felt like it was pretty hard to really pick a design that really felt simple but yet effective at the same time. As you can see, these solar panels on the side, these red wings, I grabbed inspiration from the Hubble telescope that launched about a year and a half ago, or 2 years ago, And basically, I wanted to build something simple for the body. As you can see, it's rectangular, and for the wings, I would want to plan them to be foldable so we can fit them inside a rocket. And as we can see with the tip, we would have a force sensor up here so we can detect solar radiation as it hits the satellite in space. And thank you for listening. I'm going to pass it on to Joseph now.
All right. Hello, my name is Joseph Williams. I'm going to be explaining the physics part of our project. So for our project, we chose to do the space radiation mitigation. That is basically blocking heavy atomic nuclei from damaging the things that we send into space. So the force reader acts as a way to ensure that we have deployed our protective layer, essentially, our protective shield, kind of just as a surefire way that we're not, like it's on, like it's not going to fail, we're not going to have anything that's damaged because we didn't deploy it, right? And so here we have our force reader. This is our Arduino, and this is our breadboard. This is going to be our reader to read the force. It's going to tell you the force in newtons as well as the amount of force. So it's going to say low, medium, or high. These are our LEDs here that are going to react to the amount of force put. Green is a low amount of force to no force. Yellow is going to be a mid-tier amount of force, and then red is going to be our high force. This is our force sensor. It reacts to pressure, so the more you push it, the LEDs will change. We have some resistors in here just so that we don't blow out our LEDs and ruin them when we don't need to. And yeah, I think that's it. I'm going to pass it to Luis.
Hello, my name is Luis Gutierrez. I'm an Associate of Science and Math at San Bernardino Valley College. This is my second year here, and I'm planning to transfer to Cal Poly Pomona for electrical engineering. I decided to handle the hardware and software of things. So Joseph briefly touched on it with our force sensor, what our LEDs do, as well as our LCD screen. So our force sensor is going to act as an input, so the more pressure you put on it, or the more acceleration you put on it, the more you're going to change it with the amount of newtons you're applying. And he also touched on this, the resistors. So we're actually going to take the digital input of our force sensor. We're going to see how much voltage goes through it. We're going to read it in our digital pin, and we're going to send a digital output from one of our digital pins. So either 8, 9, or 10 to our LEDs. So we're going to do this. There you go. As well as we're going to send another digital output to our LCD screen. So currently it's not working because I kind of messed it up. I put it out for a little bit. So it would display the force, the amount of newtons we're pushing, as well as the state of where the LEDs are at, so low, medium, or high. And then this potentiometer is going to help us with the LCD screen. Is going to act sort of as a volume mixer of sorts, like on a radio. So the more you increase or decrease, the more you twist it, the more voltage you let through to light up your screen. And for the software part of things, I just went on libraries for the Arduino, looked at the libraries for the LCD screen as well as the force sensor. So some things I wish I could have improved on were a Bluetooth module, so we could just have wireless communication between our Arduino and my computer, as well as being able to code something to graph out all of our sensor readings every 2 seconds, which is something I have. I can just turn it into a CSV file and put it on Google Sheets. And the last thing is just reading how fast the object was going. I wish I had a bigger force sensor, like a square one, so I could just throw something at it and it could be able to read the acceleration it puts onto our force sensor. But that's pretty much it. Some of the problems I ran into was just hardware, since it's a very difficult subject for, sorry, not hardware, software, since it's a very difficult subject for me to grasp. And that's pretty much it. Thank you.
Hello, Marcus Walker again, and that was our project. It was space mitigation radiation, and we have finished everything. We have our design, we have our hardware, we have our software, we have our physics. We have problems, but we have solutions also. We are hoping that our new club here on campus will further our findings, so to say, and all our evidence and continue it forward in the future. All our teamwork, all our hard work through the summer, classes, work, what have you. We all came together, we all made sure we did our part, and we all tried to finish this off as good and timely as possible. Thank you, and I hope you choose our school again.